Hello makers! So, you're looking at buying a hobby level 3D scanner. Well, you came to the right place. This video will be a comprehensive review of the two newest hobby scanners on the market, the CRScan Lizard and the revopoint Mini. Both of these scanners were purchased with my own money during their Kickstarter campaign, so nothing said or shown here will be skewed by any free samples or advertisement money. Let's talk packaging. First, we have the CRScan Lizard. It's kind of a mouthful, I'm just going to say Lizard and Mini from now on. The Lizard does come in this nice travel case. It's built pretty solid. It's not quite a hard case, but it holds its shape pretty well. Inside, there's a dedicated spot for the turntable and for the scanner. One annoying thing is that the power plug is a universal plug that you have to clip regional power outlet prongs onto. The way the case is designed, the charger doesn't fit nicely in it when the prongs are attached, so if you do use the case, prepare to awkwardly jam the power plug into it or constantly be detaching the prongs. We'll review the hardware next, but first let's look at the Mini's packaging. This is how mine shipped. These were placed in a cardboard box with some foam around the edges of the turntable here. Yours may be a little bit different. I splurged on the dual axis turntable, and I imagine the box that the standard turntable comes in will be a little bit smaller. You can see that the packaging is pretty basic though. There's no travel case, though the box the scanner comes in is pretty sturdy. It has that premium unboxing feel, if that makes sense, and it would work fine for transporting the scanner on the go. It has relevant spots for everything that you would need for on-the-go scanning. However, there's no spot for the turntable, like I mentioned. That being said, it would work fine in a backpack and it would protect the scanner pretty well from any accidental bumps or drops that might happen on the go. So, who gets the point? This one's tough, as if I were to be traveling with my scanner, I probably wouldn't be bringing the turntable. Your use case might differ though. I think the point should be given on the quality of the packaging and not the portability of the scanner. So for packaging, I think the Lizard gets the point here. 1-0 so far. Okay, hardware. Starting with the Lizard. First off, the scanner has some gravity to it. In your hands, it feels like a solid piece of equipment. The plastic doesn't have a nice surface texture, but at the same time, there's no flex to it, so it feels very sturdy. On the bottom, there's a standard 1/4-inch thread for tripod mounting, and the scanner by itself weighs 370 grams. Let's talk about the tripod. The one it comes with leaves something to be desired. Realistically, if you're wanting a permanent scanning setup, you'll probably want to buy an aftermarket tripod. The ball joint at the top is stiff, even when the screw's loosened all the way, so small adjustments while you're scanning are hard to make. The legs feel spongy and make adjusting the scanner a longer process than if they were more rigid. The tripod does have a cutout for turning the scanner vertical. This is advertised for handheld scanning. Personally, in my use, I found it easier and more comfortable to just hold the scanner without the tripod for handheld scanning. However, for scanning tall objects on a turntable, you can turn the scanner sideways and the notch is useful for that. Moving on to the Lizard's turntable, it's pretty basic. It doesn't communicate with the scanner at all. It takes a separate micro USB cable and just constantly rotates while receiving power. There's a spot on the bottom of the turntable for a label, but there's no label on it. Down the road, if the turntable breaks, the lack of a model number or specs will make replacing it more annoying. I'm sure this is a mass-produced product and you can probably find a million others that do the same thing, but in the software, the scan time matches up to one rotation of the turntable. So a replacement turntable might not spin at exactly the same speed, which will make using the software just a little bit more annoying. Last, let's talk cables. The Lizard uses a proprietary cable that has a nice aircraft-style connector on one end and a Y-split for data and power on the other end. The power adapter it comes with is a 12-volt 3-amp wall plug. As mentioned before, it's a universal plug and can be annoying to fit in the travel case. Overall, the cable is nice. When connected to the scanner, it locks in and it won't come out if you pull on the cable. You have to remove it by pulling on the silver metal sleeve next to the connector's end. Props for the nice cable, but minus props for it being proprietary. Okay, Mini hardware. First off, it lives up to its name. This thing is tiny in comparison to the Lizard. Overall, it feels high quality. The scanner weighs in at 167 grams with the scanner and the dovetail tripod adapter, and 161 grams with just the scanner. You can remove the tripod adapter with a flathead screwdriver, and underneath there's a standard 1/4-inch female thread for attaching other tripod mounts. One nice thing is that there's these two small holes to either side of the 1/4-inch thread that are used to align the tripod adapter so it can't rotate. These two holes are also threaded with M3 metric threads. This is awesome to see. It adds a few extra cents to the bill of materials, but it adds additional mounting possibilities. For makers doing a lot of 3D printing, M3 bolts are all over the place, so get creative and make your own mount. Moving to the back, there's a big hardware button to start and stop scans. This is a nice additional feature that the Lizard doesn't have. Last, we have the somewhat odd-looking power and data cable. While you might think this is a proprietary cable, this is actually a USB 3 micro B cable. Quite the mouthful, but a standard cable you can buy replacements of. These cables used to be pretty popular on portable hard drives, though I never saw ones with locking screws. Looking it up on Amazon, I was able to find a replacement that's even longer at 10 feet with locking screws for only $10 US. While the cable is not as slick and fancy as the Lizard's airplane style connector, this one's replaceable and I love to see that. Moving on, the Mini has a second cable in the bag. This one's a USB 3 micro B cable as well, but it's split on the other end. One connector is a USB-C and the other is a USB-A. This is meant to be used with a USB-C Android phone. Yes, that's right. The scanner does have a mobile app for Android. The USB-C cable plugs into your phone and the USB-A cable plugs into a portable battery pack to power the scanner. Revopoint really did outdo themselves on this, especially with this little phone holder that lets you attach your scanner to your phone. Looking at the tripod, it has some pros and cons. As a handle, it feels very robust with a nice surface texture on the plastic. Instead of a ball joint, it has this GoPro style mount up top. It pivots nicely and it locks down well. On top of the pivot, it has this dovetail mount that connects to the scanner. There's a release button so the scanner won't slip out on its own. There's a little play in the mount, but it's not really noticeable unless you shake the scanner, and this could probably be solved with a small bit of tape on the inside of the dovetail. Moving on to the tripod legs, they have a similar sponginess to them that the Lizard tripod did. This tripod has extending legs, which makes the sponginess even worse. The good news is that the tripod seems to hold the scanner up without the legs being extended. So unless you need the few extra millimeters of height for your scan, just leave them collapsed. Like with the Lizard, I'd recommend an external tripod. If you intend on using the dovetail quick release system, find a GoPro compatible tripod and the female part of the dovetail mount should attach just fine. Last, the turntable. I paid extra for the dual axis turntable, so it wouldn't be fair to compare it to the standard one that came with the Lizard. I will say overall the quality is pretty nice. You can control the speed that it rotates from software as well as define up to 5 different passes, each at a different angle, ranging from -30 to +30 degrees. Both scanners are unable to shut down completely when plugged in. The Lizard always runs a fan and the Mini will have a faint blue light being emitted. It would be nice if the scanners could completely shut down so they could be permanently connected to a workshop computer. As for hardware, the revopoint Mini gets a point for having a more compact design, a non-proprietary cable, and additional adapters to be able to use it with a phone. This ties it up 1-1. Alright, let's talk software. I'm sure you're just waiting for me to get to the actual scan results, but here's the thing. 3D scanning is a long process and the interface between you, the hardware, and the 3D model that gets spit out at you at the end is the software. Bad software makes for a bad experience, long scans only to have your software crash before saving is just rage-inducing, and bad UI leads to mistakes that you constantly have to go back and fix. Making's supposed to be a pretty fun hobby, and if the software for your new fancy toy is annoying, then you're going to use it less and get less enjoyment from it. So with that being said, let's move on to the Lizard. As of recording this, 2.5.2 just came out and I ran my tests on that. The previous versions were very buggy, but I'm happy to say that in the approximately 5 hours of scans that I did for testing, not once did the software crash on me. The UI is fine, but it kind of expects you to already know the workflow. So for instance, on a turntable scan, there's the initial calibration step and then the initial scan where it tries to figure out where the turntable is, and then there's the final scan where you actually put your object on the turntable. It would be nice if you could arbitrarily step around and choose which one of these you want to do. If I'm going to manually be deleting the turntable data and not using the auto delete, I don't need that initial scan. And if I already have my settings dialed in, it would be nice to be able to skip the preview. That being said, the software is overall pretty workable. I like how I was able to modify the point clouds in the scan software before alignment was done, and while the processing was a bit slower than the Mini software, the output looked really good. There are a few annoying things. One is that after a scan is complete, you don't have the option to throw away the data without it first automatically doing some amount of processing. If I know a scan failed, just let me throw it away so I can get to my second scan quicker. Overall, the software is passable. I can do almost everything I need to in the software, and it works well enough for all of those tasks. Moving on to the revopoint software that's used for the Mini, it's surprisingly slightly worse. Reading things online, they made it sound like the revopoint software was better than Creality, but in my opinion, it's kind of worse. The software was easy to find and install, but once I got it up and running, I spent a good hour trying to figure out why my dual axis turntable just wouldn't work with my computer. Windows could see the Bluetooth device, but the revopoint software couldn't. Eventually, I tried on a different computer, and that one was able to see it instantly. The Bluetooth turntable connects to the Mini scanner over Bluetooth, not to your computer's Bluetooth. I confirmed this on the other computer by disabling the onboard Bluetooth and rescanning from the Mini software, and it was still able to find it. So, what a strange bug. Revopoint, please fix. Keeping with the turntable functionality, the software does not automatically end the scan after one turntable rotation, unless you're using their dual axis turntable. The Lizard software does, but in a crude way where it stops after a set amount of time. This means the Lizard software won't play nice with aftermarket turntables. A fix for both softwares would be to have an explicit turntable mode like the Lizard software does, but allow a configurable time before the auto end for the scan happens. Touching on the Android app, there's no settings menu where I can connect to the turntable, and there's no way to just make the turntable rotate without it being controlled through the scanner app. This basically means that when you're using a phone, you can only freehand scan things. Besides that though, it behaves almost the same as a desktop app, with the additional ability to connect wirelessly to the scanner as well as through the cable. I didn't try this out because my phone supports connecting over USB-C. Moving on to the actual scanning, changes you make in the preview tab for brightness don't carry over to the scan tab. So you'll get your settings dialed in, go to start a scan, and then have to cancel it and start all over because you got your settings wrong. I do have to say though, the preview and scan progress on the Mini software is easier to tell if something is under or overexposed, and the results in the software are closer to what you can expect your STL to look like. There's no way to edit point cloud data in the scan software. The only thing you can do in software is fuse the points as well as mesh the fused model. You can fill holes while meshing, which is nice, though you aren't able to do any trimming in the software. At least for my workflow, I like to trim junk data away before meshing and filling holes. Basically, any editing is expected to be done in external software. Revopoint does have a free program to edit meshes and point clouds, which includes a way to align multiple models together. Sadly, it can only combine 2 models at the same time. So if you want to align 3 models that you've scanned, you're first going to have to load the first 2, combine those, save it, load the saved output, load your third scan, and then align that. Very annoying. In contrast, in the Lizard software, you can align multiple scans automatically at once with one button click. Maybe you can do this in different external software for the revopoint, but for this review, I'm really just focusing on the revopoint software. So let's talk points. I'll cover hand scanning later on, but just for now, no, it's not that great, and with the Android app not being able to connect to the turntable, and handheld scanning basically being the only thing it can do, it's not going to be adding any partial points to this category here. So for the software, surprisingly, I have to say that Creality just takes a point. Okay, it's the moment you've all been waiting for. Let's compare the scan results. Each of the scanners performed 6 scans with the turntable, 2 in bright direct light, 2 in diffuse room lighting, and 2 in dark conditions. The best scan from each lighting condition were kept and compared. For the Lizard, each of the lighting condition tests were done twice, once in texture mode and once in geometry mode. To keep things fair, the Lizard turntable will be used for both scanners. As you can see, the Mini does a really good job at pulling out additional detail from the model. That isn't to say that the Lizard results are bad, but the Mini is definitely more detailed. You will notice on a few of the Lizard scans there's some ugly artifacting under the model's chin. This isn't the fault of the scanner. The Lizard software defaults to filling holes, whereas the Mini software does not. I left the scanning settings pretty much default, hence the difference. The Lizard software does its alignment of multiple scans pre-meshing, so any holes in the model are going to be filled by future scans that you do before the hole filling algorithm makes those jaggedy artifacts. Looking at the results, if you're doing anything where a resin printer is involved, then the Mini really is your tool. That being said, for scanning objects to use as reference geometry in CAD, the Lizard does just fine. Printing the scans on an FDM printer, the outputs are pretty comparable, as you can see here. Each of these were printed at 0.15mm layer height with a 0.4mm nozzle, so for FDM printing, even though the Mini has more detail, the scanner probably isn't your limiting factor. Regardless though, for scan quality, I think it's a solid one for the Mini, especially if you're reverse engineering small parts or recreating miniatures. Well, I guess this ties it back up. 2-2. Quality isn't the only thing to look at though. Next, let's compare dimensional accuracy. This block is 40mm in all dimensions, plus or minus a few tenths of a millimeter. Let's do a scan and see how accurate it is to the real object. Each scan was done with the Lizard turntable again, using the best lighting and brightness from their past test. First off, whoa, look at how crisp the details are on the X, Y, and Z here for the Mini. Very impressive. With the turntable, the Mini was off by negative 0.54mm in the X direction, positive 0.04mm in the Y direction, and negative 0.51mm in the Z direction. This gives an average variance of 0.36mm. Now let's flip over to the Lizard. With that, we have negative 1.01mm in the X direction, negative 0.93mm in the Y direction, and negative 1.67mm in the Z direction, for an average variance of 1.2mm. Both scanners had an outlier, with an impressively low 0.04mm for the Mini, and a somewhat respectable outlier of 1.67mm on the Lizard. Removing those, the Mini still wins with an average variance of 0.53mm, while the Lizard had an average variance of 0.97mm of average variance. To give you an idea of how accurate these are, a sheet of printer paper has a thickness of about 0.1mm. So the Mini is off by 3 to 5 sheets of paper in each dimension, while the Lizard is off by about 10 to 12 sheets. Both pretty impressive, but the Mini takes the category. 3 Mini, 2 Lizard. Next, let's do the same scan of our calibration cube, but this time in handheld mode. If you're doing large scans, I assume dimensional accuracy is probably going to be your biggest factor. So we'll look at our test cube and then scan some larger things afterwards that require the software to track out a frame and do things like that. For those tests, we're going to be using my vise covered with a bunch of tracking dots, an old amplifier with a lot of features for the scanner to track, and then as a torture test, a ubiquity access point that I have on my wall. This is a medium-sized object, but it doesn't have a lot of distinct geometry, so I imagine it's going to be really hard for the scanners to track that. So first up, the handheld scans of the calibration cube. The Mini had a real difficult time tracking the cube, so I had to make sure to be very quick on the scan so the scan wouldn't mess itself up. Not only that, but I couldn't successfully scan it in feature tracking mode. I had to put the cube on top of the Mini's turntable, which is loaded with a bunch of tracking dots, and then do the scan in tracking dot mode. Sadly, this is going to be a reoccurring theme. Because of this, there was no definitive edge captured on the back of the cube. I had to guess on where the side of the cube ended in the process scan. The Mini did surprisingly well with an error of -1.57, -1.91, and -0.42 millimeters with an average variance of 1.3 millimeters. However, I wouldn't be confident on the measurements if I hadn't already known that the cube was 40 millimeters. After all, why would you be scanning an object if you already knew the dimensions? This really just comes down to the scan messing up and me not getting a sharp, crisp edge for the back of the cube. The lizard was a different story. While I did have to redo the scan once to some skew on the first scan, the process felt smooth and predictable. When tracking was lost, it would normally go back to the correct location without messing up the object. I got a variance of -0.41 millimeters, +1.96 millimeters, and -0.28 millimeters for the scan errors. This gives an average deviance of 0.88 millimeters, which is pretty impressive. Alright, let's move on to our large test objects, starting with the lizard. The lizard was able to capture the shape of the vise both with and without tracking dots. However, when processing it, the software did want to take away a lot of the scan data. The remaining data looked really true to the vise, but if I want to be able to have a real messy STL export with a lot of floating islands and polygons, I should be able to get that, because that gives me more data that I can use in CAD to pick up on reference geometry. Sadly, the software just didn't want to let me do that. The story was similar on the amp. It was able to capture the spacing of the components and the texture of the amp. The scanner struggled to pick up both the bright silver surface of the amp and the black connectors, but it was apparent where the connectors should be, so for the sake of scanning in reference geometry, it would have done the job, if it would let me export it. Similar to the vise, it only wanted to export the bit of the scan that it could make a 3D-ish shape out of, which in my case was kind of just the edge of the table the vise was sitting on. Again, if I want to do a scan of just a flat thing with a bunch of noise and holes in it, just let me export that, Creality, please. To make matters a little bit worse, I couldn't find a way to export just the point cloud data that could be used in another scan software. It does let you export a file, but it's in an ASC format, which, looking it up, it's used for like terrain mapping or something, and not a lot of programs support it. So odd and not all that useful. Last, on the torture test, the scanner was not able to keep track of the access point. It got confused and thought it turned 90 degrees during the scan. Moving on to the Mini, it did worse in every category, and not like a little bit worse, like worse in every category. The vise just would not scan without tracking dots at all. And even when I loaded the thing up with an entire sheet of tracking dots, it would kind of track it a bit and then lose track, and then when it would regain track, it would start throwing the newly captured data in just random directions all over. I probably spent hours, like multiple hours, getting this to work, and I couldn't get anything that looked remotely close to a vise. What you're seeing on screen is the best out of all of those attempts. The scan of the amp was abysmal. The scan started, and then it just skewed and stretched the object into oblivion.
By the 9 divines!
The access point was even worse than the lizard. It just spun around in circles and it couldn't figure out what was going on. Basically, all of the mobile scans were useless. I tried both on the computer and on the Android phone, hoping that the Android phone app would be a bit more optimized for doing handheld scanning, but no, the scan results were equally as bad. So, solid victory for the lizard. This brings it back to being tied at 3-3. Alright, lastly, let's look at the scan volume and some of the other features of these scanners. Starting with the Mini, it could get right up to an object, to the point where its own light was overpowering the sensor. I was able to get a somewhat readable scan at 4 inches to an object. The scanner worked best at around 6 inches, which is still pretty close up, and it maxed out at around 10.5 inches, even on large objects. For instance, here's an aerosol can, and this is how much I could scan at 10.5 inches. Looking at the lizard, the closest it could scan to an object was 7.5 inches with an optimal distance of around 11 inches. Moving the scanner back to 15 inches, it could still get a scan, but it was only seeing the closest part of the object, not the part of the object that was the furthest to the scanner. The tracking in the software is really good, so it was still able to do a full scan of the object, but this probably isn't the optimal way to do a scan. Going to our aerosol can, this is how much it could scan at about 15 inches with the scanner positioned sideways, so it got more additional vertical height. Pretty much the whole body, just missing the top part of the aerosol can. So when we're looking at what you can scan on a turntable, the point goes to the lizard. The last thing I want to talk about is texture mapping. This isn't something I personally plan on using, but if you're scanning objects to use in a game or some 3D application or something, this might be a useful feature. The Mini does have a built-in color camera, so you can just scan with textures enabled and save the object as a OBJ or PLY, and that's going to contain the color data as well. The Lizard can also record texture, but only in black and white. This seems kind of useless, but when you think about it, they are probably using that data for object tracking, so at least they expose it to you so you can save it. Creality does sell an external color kit for the Lizard, where you can use a separate camera to capture color texture, but I didn't pay for that, so I can't really compare it. Because we're not including paid add-ons, the Mini gets the point here. Though I imagine if you're using an external camera, it will capture higher quality texture data than what the Mini has built in. So, with the Mini getting that last point, let's see, carry the 1, divide by the cross product of the reciprocal. Wait, does this mean they tied 4-4? I guess it does. But each of these categories probably matters more or less to different people, so maybe your score isn't a tie. I know for me, I'm torn. I bought both of these expecting to test them, find the one that works best for me, and then sell the other on eBay, but each of these kind of fills its own niche. The Mini is better for turntable-based scans on small objects, and it's more dimensionally accurate, and the scans are more crisp, something kind of useful for finding edges and referencing it when looking at your scans in CAD. However, the handheld mode is just pure garbage. On the other hand, the Lizard can do turntable scans fine, not as good, but adequate enough unless you're doing miniatures on a resin printer. It also has the benefit of being able to do handheld scans, which is great. Sadly, it doesn't have a mobile app, and if you wanted to do it truly portable, you're going to need to bring a laptop and have a 12-volt, 3-amp battery pack to sub in for the wall wart. So if you do want to have a portable scan set up, it's going to be a little bit more involved. I think in the long run, if revopoint puts the effort into their scan software, I think they could have a real winner with the mobile app and USB battery pack use. They just need some real talent to overhaul their object tracking. Well, there you go. 2 full days of testing, hopefully condensed down into a manageable video. If you like this, share it with your maker buddies, especially if they're looking into getting a scanner. Subscribing really helps my channel. And if you made it this long, consider that I have other videos that are probably just as informative and other cool projects and stuff like that coming down the pipeline. So, hey, smash that subscribe button. Really, get in there and smash it real good. Pound it into oblivion. Anyway, if you hated that the scanners ended up in a tie, well, YouTube removed their dislikes, so like this video in rage to show how annoyed you are, and if you're okay with it being a tie, well, then like the video because you're an awesome person who doesn't expect everything in life to be binary. Anyway, for me personally, I'm probably going to hold on to both of these scanners, at least for now. If revopoint gets her handheld scanning working, that might change in the future though. Well, with that said, hopefully I see you around. Cheers!